Elon Musk, this sodium 4.0 battery will change everything. Tesla has been at the forefront of the electric vehicle technology and has also been heavily involved in developing advanced battery technology to power its vehicles. In April 2020, the company announced that it had developed a new battery cell that it referred to as the 4680 cell, named after its dimensions of 46 millimeters in diameter and 80 millimeters in length. The new battery cell is said to have several improvements over the previous battery technology, including a significant increase in energy density. But new reports have come in about an even better, efficient, and cheaper battery. So what makes the cost of this groundbreaking battery so low? What are the other advantages that come with it? Join us as we go through all this and more in today's video. The cost of lithium has taken a huge hike from $4,450 a ton in 2012 to $78,032 in 2022. That's almost an increase of 1,654% in the past decade, with an incredible 480% increase in just the past year. Now, what if the new battery costs only about $15.15 per kilowatt hour, compared to the $101 per kilowatt hour price that the lithium-based batteries provide? This is exactly what the new battery by CATL has to offer. Sodium-ion battery is a type of rechargeable battery that uses sodium ions as the charge carrier instead of lithium ions. The first generation of sodium-ion batteries were developed in the early 1990s, and since then, research has been ongoing to improve their performance and reduce their cost. CATL, or Contemporary Amperex Technology Company, is a Chinese company that is one of the leading manufacturers of batteries for electric vehicles and energy storage systems. Founded in 2011, the company has grown quickly and has become one of the largest battery manufacturers in the world. The batteries produced by CATL are used by a wide range of car manufacturers, including Volkswagen, BMW, and Toyota. The company also supplies batteries to various other industries, such as energy storage, consumer electronics, and power tools. In 2020, CATL became the world's largest EV battery maker by production volume and also announced a plan to build a battery factory in Europe. This battery technology development has been in the fast lane for the last few years. But with that being said, CATL has set up a large supply chain for the batteries and has answered negotiations with some car makers about the possibilities of a sodium-ion battery use. Sodium-ion technology is ready, cheap, and most definitely safe, but the real question is, can it match up and most importantly, outplay the existing lithium-ion batteries? Elon Musk tweeted that the price of lithium has gone insane levels. One of the most advantageous factors of sodium-ion batteries is the substantially low cost of sodium as compared to lithium. This is because 2.3% of the world's crust, making it over 1,000 times more abundant than lithium from the perspective of raw materials, is in the battery. Comparing the drastic price difference between lithium and sodium, it is evident that sodium-ion batteries would be almost 190 times cheaper than lithium-ion batteries. One of the key strengths of the CATL batteries technology is its high energy density, which allows for longer range in EVs. Battery density is an important factor in the design and the production of EVs and energy storage systems, as it directly impacts the range and performance of these systems. Higher battery density allows for longer range and more efficient use of space, which are both critical for the widespread adoption of EVs and energy storage systems. CATL is at the forefront of battery density research and development, and has made significant strides in recent years. The company's battery cells have energy densities up to 250 kilograms, which is the highest density in the industry. This means that the CATL battery cells can store more energy in a smaller volume than many other battery cells on the market. One of the key technologies that CATL uses to achieve high battery density is the use of lithium nickel cobalt magnesium oxide cathodes. NCM cathodes have a higher energy density than the traditional lithium cobalt oxide cathodes, which allows for more energy to be stored in a smaller volume. CATL also uses a unique coating process for its cathodes, which further increases the energy density of the battery cells. Through the process of pioneering AB battery system integration technology, CATL has also achieved a mix of sodium-ion and lithium-ion batteries, allowing them to complement each other and thus increase in the energy density of the battery system. This new approach allows sodium-ion batteries to be able to support EV models with a range of up to 310 miles, while the 4680 battery model has only a 270-mile range. CATL has revealed that sodium has a better conductivity and that the concentration of electrolyte can be reduced, which also reduces the cost by about 85%. The price of a Tesla 4680 battery would be $101 per kilowatt hour. By comparing the difference in the power production of the two batteries, the new battery cost can be calculated at roughly $15.15 per kilowatt per hour, or nearly 7 times less than the 4680 battery. If you're an owner of a Tesla Model 3 standard range with an estimated battery pack battery capacity of 50 kilowatt per hour, instead of having to pay $5,050 for a revolutionary game-changing battery, the cost is extremely low. The company's batteries are also designed to have a long lifespan, with a projected lifestyle of over 1,500 cycles. This means that the battery can be charged and discharged over 1,500 times before its capacity drops to a certain level. This is significantly longer than the industry standard of about 500 cycles. Hearing all this, a question might have come to your mind about how long it takes to charge this revolutionary battery. CATL sodium-ion cells can charge in 15 minutes to about 80% at room temperature, while the fast-charging facility at a public station, the Model Y from Tesla, recharges from 0 to 80% in 32 minutes, which is over 2 times longer than how much time it takes for the sodium-ion battery. Last year, CATL had unveiled its first sodium battery prototype, and it also came out saying that it's been focusing on developing new technologies for a second-generation sodium battery that can generate 200 watt-hours per kilogram, in contrast to mainstream lithium-ion batteries that have a 200 to 300 watt-hours per kilogram. Although their lower energy density is improving constantly, the first generation of sodium-ion batteries is better than lithium cells from 6 to 7 years ago. The first generation of sodium-ion batteries used a graphite anode and a vanadium pentoxide cathode. These batteries had a low energy density and a short life cycle, which limited their practical applications. However, research has since led to the development of new anodes and cathodes that have improved the performance of the sodium-ion batteries. One such development is the use of the sodium metal oxide as the cathode material. Sodium metal oxide has a higher energy density than the vanadium pentoxide, which has led to an increase in the energy density of the sodium-ion batteries. Additionally, researchers have developed new anode materials, such as sodium-based alloys, which have also improved the performance of the sodium-ion batteries. The first generation of sodium-ion batteries can be used to various transportation electrification scenarios, especially in regions with extremely low temperatures where it would become an outstanding advantage. Also, it can be flexibly adapted to the application needs of all scenarios in the energy storage field. Despite the advancements in technology, sodium-ion batteries still face some challenges that hinder their commercialization. One of the main challenges is the low conductivity of the cathode, which leads to poor rate performance and high resistance. The development of a stable and efficient electrolyte for sodium-ion batteries still remains a challenge. Sodium-ion batteries have a wide range of potential applications, including in electric vehicles, grid energy storage, and portable electronics. Due to their lower cost, higher energy density, and the wide availability of raw materials, they have the potential to become a viable alternative to the lithium-ion batteries. It is usual that several new batteries are being made, found and investigated in several labs, but it often takes them 5 or even 10 years to reach market, or they will be released soon. CATL has been working on developing a recycling system for its batteries, with the goal of recycling over 80% of the materials that it uses in its batteries. This not only helps reduce the environmental impact of battery production, but also helps reduce the cost of raw materials. This will also help to create a sustainable battery production cycle, where the end-of-life batteries are recycled and the materials are reused in new batteries. CATL is one of the first companies in the industry to establish a recycling system for its batteries, which is important for the development of the electric vehicle industry. So what do you think? When do you think this new life-changing battery would come out? And how do you think it's going to impact the direction of the future of transportation?